Okay, it is my pleasure to introduce your presenter tonight. I'm really excited about this talk. Dr. Dana Wright is a research scientist and principal investigator with the Cooperative Institute for Climate, Ocean, and Ecosystem Studies at the University of Washington. She's not in Washington State right now. She is joining us from the East Coast. So it's like 9 o'clock her time. So gold star for you. So joining us later in the evening. Thank you for that. Her research uses underwater microphones, so hydrophones, to listen in on marine mammals throughout Alaska and the North Pacific, helping reveal where whales occur, when they migrate, how they use their habitat, and how changing ocean conditions influence their lives. Her research focuses on North Pacific right whales, bowhead whales, and humpback whales, with a particular interest in understanding how climate change is reshaping marine ecosystems. So, again, we're so thrilled to have you, Dr. Wright. And whenever you're ready, take it away. Thank you so much.
I am ready. Thank you so much, Tracy. And thank you to everyone for tuning in. I saw a bunch of folks listening East Coast as well. So we're all rocking the 9 o'clock. I really appreciate that. And I just really wanted to thank the Whale Museum. This feels like a full circle moment because I grew up in Idaho, which for those that don't know, it's sandwiched between Washington State and Wyoming. So there's no ocean nearby. But one of the really cool things I got to do as a kid was I did actually get to go to the Whale Museum. And so this is a poster that I got. I think the poster lists 1996. So I don't know if that's the year that we got it, but it feels really awesome to get to present to you all. So thank you so much. And get to present about North Pacific right whales, a species that I have been researching for a while and I think is quite cool. So really what I'm hoping that you guys get away from this talk is learn a little bit about the history, science, and conservation of North Pacific right whales. But I want to take a step back in the beginning and start out by asking a pretty basic question of what even is a right whale. So right whales are part of the genus Eubelina. So that's under the family of Balenidae. So they have a cousin called the bowhead whale. That's an Arctic whale. They share some similar morphology, but today we're talking about right whales. So there's three species of right whale recognized today. There's Eubelina japonica, so the North Pacific right whale. That's who we're talking about. There's also Eubelina glacialis, right whales in the Atlantic, in the northern hemisphere, and then Eubelina australis, so our southern right whales. And one of the interesting things is that it really wasn't until 2000 that people were having even discussions about the idea of three species. Up until that point, there was only two. There was only Glacialis and Australis. So it's pretty much any right whale in the northern hemisphere. We're lumping it together under the same species, whether it's in the Atlantic or the Pacific Ocean, and then anything in the southern hemisphere is going to be Australis. So I'll talk a little bit later in the talk about how it came to be that we even recognize this species and what that means in terms of conservation efforts. So let's look a little bit into their morphology. So these are pretty big animals. So at full size, and they do have sexual dimorphism, meaning that females are bigger than males at the same age as adults. They get on average about 50 feet. They can get a little bit longer, but that's a good average. You can see that their body is pretty dark and that they can have white patches on their belly. Their pectoral fins look like big paddles, almost like squares. And so very different from something like a humpback whale. They look like they have these frowny faces, right? They constantly have a frown. And I'll talk in a couple slides about why that is. And then they have these kind of bumps. It almost looks like these hard kind of patches. And I'll talk about that on the next slide. But let's compare their size because it's kind of hard to wrap your head around something 50 feet long. Let's compare it to a big bull southern resident killer whale. So that's about twice as long as these guys. And if you've had the pleasure of seeing one of these killer whales in person, I mean, it is just unbelievable how large they are. And then to think that this right whale is twice as large is it's hard to wrap your head around. But maybe you haven't seen a whale, you haven't been on a whale watching cruise before, but you've been to a zoo. A right whale is about a little over twice as long as an adult giraffe is tall. And maybe you haven't seen a giraffe in person, but you've seen this exotic animal called semi-truck on a freeway. And these guys with their full trailers on the back are about 72 feet. So right whale is about 2/3 the length of a full-length semi-truck. So again, quite large animals. And you can also see that they are kind of round around the middle. We call them rotund. So they're not as slim as some other species, like, for example, a fin whale, and that they don't have a dorsal fin, so they don't have a fin on their back. Let's compare them to some other whales. So they're pretty, I would say, medium size for a baleen whale. They're slightly larger than a humpback whale, for example, but much smaller than a fin whale. But they are comparable to a sperm whale, which is the largest toothed whale. So I brought up those kind of hardened patches. They almost look like, barnacles or something on the front of the head. So those are actually called callosities. And if you start zooming in, I know that Halloween is still months away, but it starts to get very creepy crawly, because you think, are those things alive, right? And that's true, yeah. So what you're seeing, the lighter colored areas are actually aggregations of sea lice. So the sea lice is occupying areas of roughened skin on the animal's head and other parts of the body, and they're not parasitic, they're not sucking their blood or anything, but they are kind of feasting on sloughing skin in those roughened areas. And where the whale develops, so the individual patches that it develops of roughened skin, is unique to the animal, so like a fingerprint. They're born with these roughened areas of skin, and then they kind of inherit the sea lice from their mothers. So as mammals, they do nurse with milk, and so while they're doing that, the mother is kind of transferring some of the sea lice to her calf. So the callosity is actually extremely important because, like I said, it's like a fingerprint. So for southern resident killer whale, you get the saddle patches on the back. From those, you can identify individuals, right? Because they're unique to the animal. I think the other classic example people think of is the humpback whale tail, where the underside of the fluke is unique markings to the individual. And that's very, very helpful when we're doing science on these animals, because if you remember, like, their bodies kind of, it's simple looking. It's kind of one color, maybe some patches on the belly, but it's unlikely they're gonna roll over and show their belly. So having these markings on the head where we can identify individuals is extremely helpful because it allows us to answer some pretty important questions. Like, for example, if you're the scientist in the upper left who is searching for right whales and you see one, you take a picture, it's helpful to know, is that the same whale that I saw this time last year? Is that the same whale I saw yesterday? How many whales are in this area? So you can say, okay, yep, that's whale 453. We see that whale every May when we survey this area. And from that, we can start to answer questions about the population dynamics, how many animals are in an area, what is kind of the demography, like, is there a bunch of calves, juveniles, right? Does 453 often associate with a calf? We can learn a lot about these animals from simply just taking a picture of them. One of the interesting things is that the left and the right side of the face can have different markings. So if you see one, it's very helpful to try to get a picture from both sides, because while we do have a big catalog, so we say, okay, we've got this picture, does it match any in our catalog? We might only have a picture of one side of the face. So we're always trying to improve our catalog. So another identifying feature, like I told you, is they have that kind of frowny face. And that is so that they can house these huge plates of called baleen. So they are baleen whales, so they don't have teeth. Instead, they have these racks of baleen which grow from the upper gum. And I actually have a bowhead whale piece of baleen with me. You can see it's extremely thin. And so there's hundreds and hundreds of sheets which are growing from the top of the gum down like this. And they have a kind of a furrier side on the inside toward the mouth. And this is made out of the same stuff as your hair and fingernails. So it is very flexible, but and it's also relatively strong. So let's take a closer look. This is that same animal. And I will mention that this picture, the black and white picture, is from a male who was accidentally killed off of British Columbia in 1951. So he had just reached sexual maturity, so he's about 12 meters long. For reference, you can see that his head is huge. And actually, one of the fun facts about right whales is that their head is about a third of the length of their body. So they put a lot of a lot of investment into having a big head, and that is, again, to help them with their filtering apparatus to feed. So this is that same whale zoomed in with the human. Let's say he's about 5'10", 6 feet. So you can just get a scale again of how large these animals are with this huge tongue and its long sheets of baleen. Those are probably 6 to 8 feet at their longest. And they use this to collect their food. So these guys, even though they're so huge, they feed on some of the tiniest stuff in the ocean called copepods. So these are a type of crustacean, but they are about the size of a grain of rice. And they have the energy density of about a piece of bacon. So they have some protein, but they have quite a bit of lipid or fat. And that is predominantly what the animal uses for its energy. So it wants to eat a whole bunch of these little floating bacons to not only feed itself, give itself energy in the moment, but it will, any excess energy, it will deposit into its blubber or into its fat layers, which it can then use as a data source to metabolize and feed on at times of the year when food might be more scarce. So I'm going to show a little video of how right whales feed, because you might be wondering, how do they feed on something that's the size of a grain of rice? And what they do is they allow the copepods will aggregate, so they in big swarms of thousands to hundreds of thousands. And so the whales will come upon these patches, and it's called mowing the grass. It's very simple, right? He's just swimming pretty straight with his mouth open. You can see the baleen kind of flexing. So he's going by. You're seeing those hundreds of sheets of baleen. You're going to see his eye in just a second. And what happens is that he lets physics do all the work, right? He says, I'm going to let the water come in. It's going to pass passively through these sheets of baleen, so between the pieces, but the inside is going to be almost like hair, right? And so this is going to catch all of that, all the copepods on the inside. Just going to close his mouth and use his big tongue and do a swallow. So he doesn't have to spit any of the water out. It's a very clever, very simple design. And so you can see, right, being rotund and having big paddles just helps you kind of maintain your position in the water while you mow the grass. So North Pacific right whales are in the Pacific today. Recognize two different populations, a Western and an Eastern, and kind of their distributions are shown with those lighter blue areas. You can see the map is kind of biased toward looking at the upper end, right? Like we're looking at Alaska, California, but we're not getting all the way down to California, for example. And this is partly because I'm really focusing on where we know more about their distribution. So what we know the most about them is from their time on the feeding grounds, at least from the contemporary population or the population that we know of today. But one of the big questions is kind of their southern extent and southern range, and I'll talk more about that later. But we do see two different populations. You can see they're kind of nicely divided, 180-degree latitude, where the Western population feeds off of Russia and Japan, and the Eastern population feeds, Alaska, Gulf of Alaska waters. So today, the Western population is thought to number up to about 1,000 animals, anywhere between 500 and 1,000. And you might be wondering if that's a lot or a little. That is a little, I'll explain on the next slide, compared to what. But still, 1,000, if we compare it to our Eastern population, which is thought to have less than 50 animals, it's a markedly larger population in the Western North Pacific. So the Eastern North Pacific right whale is considered one of the most endangered baleen whale populations on the planet today. It is listed as critically endangered and is listed on the IUCN Red List. So this is the population that I'm going to be focusing most of the talk on, predominantly because these are just the animals that inhabit US and Canadian waters, and so the ones that I study and know a little bit more about. So yeah, the question becomes, 1,000, is that a lot? Is that a little? It's a little. So these animals were thought to number, easily greater than 20,000 animals pre-industrial whaling, but that greatly changed in the late 1830s, once right whales were quote unquote discovered by Yankee whaling vessels. And specifically, it was the ability for these industrial whaling fleets to have vessels where you could process an animal and extract the product that you wanted from it, whether it was the baleen or the blubber at sea, on the boat. You don't have to take the whale and bring it back to shore. And so that really changed the game with how many whales could be taken in a season, and just how rapidly a population could decline. So to illustrate this and really kind of impress upon you the speed at which the population was dramatically impacted, I have this little animation, and I know it's not the most high tech, but hopefully it gets the job done. So this is pretty cool because this is all data from the New Bedford Whaling Museum. So you yourself can go online and download all this data. I'm only showing a small snippet centered in the Pacific and only a little over 1 decade, but you can look kind of everywhere in the world at different times. So it's really cool to play with. But I'm going to be showing from January 1838 to about 1850, which is going to be in the upper left. And then to orientate you, the light gray dots, so that you can think of as whaling effort. So that is, every point is a lat long that was recorded in a whaling logbook. And these are mostly American whaling fleet data, I believe, but I don't think that's exclusive. So this is saying from January 1830 to December of 1839, this is all the locations where they again recorded their position in the Pacific. If it's a black dot, that's where the vessel actively was in that month year, so January of 1838. And then if that dot is filled with a color, that means that a whale was either sighted or was struck. So the two kind of colors you're going to see a lot of at this time in history is turquoise, which is sperm whales. And I'm pointing the whale's head toward where kind of the majority of sperm whaling effort was during the 1840s. But I highlighted 1920s, 1930 when, really they were targeted at that latitude at that time. And then of course, right whales. And I'm pointing his head again toward the North Pacific. And that's where I recommend you kind of focus and just kind of follow these track lines and see what our whaling vessels are doing. You'll also see some orange down south. And again, that's going to be Whaling australis or the southern right whale. Okay. So let's start our video. So you can see there's not very many track lines up in the North Pacific in the decade of the 1830s, but in 1839, a vessel goes up and it collects a fair number of right whales. So bam, we get into the next decade and you can see a huge change in effort. So this means that a lot of the whaling fleet was going to the North Pacific over this decade. And if we follow it along, you see kind of a seasonal progression where the whalers come in spring into the North Pacific. They kill a whole bunch of whales every year, and then they move south. Oftentimes they go through Hawaii, which is where they will drop off the oil and the baleen, and they go down to the southern hemisphere in winter to target southern right whales during their austral summer. So you can see even by 1845, the majority of the fleet is going to the North Pacific to target right whales, and that they are targeting both the eastern and the western. More animals are being taken. Again, Hawaii is a common port. And so one might be wondering, actually, I'm just let this play and then say my next thing. Okay, so we're about to jump to the next decade, right? And so we can see within 1 decade, right, that the Gulf of Alaska, so kind of the eastern right whale population area, has pretty much been abandoned. And that is because the population was already low enough that it wasn't in the whalers' interest to try to find the few animals that they could come across. It made a lot more sense to go to the Western North Pacific, where they could come upon gobs and gobs where there still were. And because again, this is a fishery, it's a money-making machine. They're trying to fill up their quota as quickly as possible. So you might be wondering, it looks like a banana, like why was right whales so heavily targeted at that time? It's because right whale was really an ideal whale at that time in history to harvest because it's baleen. So baleen, like I showed you, is very flexible. And this was the time before plastic. So it was used for all sorts of household products, which we today use plastic for. For example, a comb. I think the classic example people think of is the corsetry. So the kind of the boning structure in corsets of fine women's clothing at that time. But it was fishing poles, buggy whips, shoe horns, umbrella pole, like just so many household products were using baleen. And because right whales make that really long baleen, you could have those big sheets that were really flexible but strong. In addition, like I said, right whales are quite rotund. So per animal, they have a lot of blubber, which can be boiled down into oil and put in barrels. And that oil could be used in all sorts of stuff. Gas lanterns, candles, soaps, you name it. So one animal could yield a lot of product, which could be sold on the market. And so that is the predominant reason why these guys were considered the ideal whale at the time. So from about 1855, I would say, of course, if a whaling vessel came upon a right whale, they would take it. But at that time, they were really taking what they could find because they were really, really efficient. But in addition to the kind of offshore efforts, there was still shore-based whaling. And I will say after about 1900, that is what most of the catches of right whales are. And I'm using this photo for reference. So this is an animal that was processed at the Port Horbourne whaling station off of Kodiak in the Gulf of Alaska. And I just think this is a devastating, fascinating picture because this is of a female and she is on her back. So the person standing on top of the whale is standing on her belly. And you can see her two pectoral fins kind of up like this. And if you can read, it's very faint, but if you can read, it says this female was 15 feet high, 22 feet wide, and 65 feet long. So I told you that on average, North Pacific right whales are about 50 feet. So this female is 65 feet. That's a very, very healthy, in her prime female, which was likely contributing very healthy, robust calves. And so to know that she was removed from the population, it says approximate weight is 250 tons. So you just get an idea of how large they are. But it's sad. I think that she was taken, I want to say 1923, but between 1912 and 1925, I feel confident about. So let's talk about protections, right? So 1935, we had the Convention for the Regulation of Whaling. In 1946, International Convention for the Regulation of Whaling. So these were the first kind of global discussions about whaling. So not just within your country, but let's kind of collaborate. And really, right whales and gray whales were talked about, and it was from the lens of they're really important. They produce an important product, baleen and oil, and we're having a hard time finding them. And so let's pause. Let's do a moratorium. Let's give it a couple decades. Let's let them recover, and then we can start to whale again, but maybe do it in a more sustainable way, right? And at this time, this was a big disconnect between that idea. 20 years, they'll recover back to the 20,000 that they were, and the reality of these whales' biology and physiology. So, for example, a healthy North Atlantic right whale takes about 3 years to, so about 3-year cycle when a female will produce a calf. When she's unhealthy, it's 5+ years, and she's not reaching sexual maturity till about 8. So if you're saying I'm going to give 10 years, and you just had a female calf born, in 10 years she's only been able to add 1 calf to the population. So you can imagine that just the timeline is very, out of proportion to just the few number of animals left, and the big task of recovering to such a large population. So at this time, it is what was proposed was, again, a voluntary moratorium pause on right and gray whaling. And notably, Japan and USSR did not sign at that time and did continue to whale. I have this picture because you can see that there are penguins in the background. So it's likely that this whale meat actually came from Southern Hemisphere, which is where a lot of whaling at the time, the late 1940s, 50s, was happening. And I do just want to call into this space that this is the post-World War II time when many countries were recovering, and food for your people is challenging. And so it's always a complicated discussion about whaling and protections, etc. But continuing, in 1949, the IWC was formed, International Whaling Commission. And I love this photo because you can see there's names of important people, I'm assuming, written in. And this is actually from the Smithsonian website. So I don't know if you know this, but you can Google, National Museum of Natural History or the Smithsonian, and everything that you see, like if you go to DC and you go to the Smithsonian, they do have cataloged online. And so you can, if you're, for example, interested in whaling and the US kind of history of it, you can do some deep dives and you can find photographs like this, you can find correspondence. And so it's just, I truly love museums for the repositories that they are. And the Smithsonian obviously is it's our national collection. There's so many cool things hiding there. So this next round, late 1940s, was again this pitch to global moratorium, like let's stop right whaling. And Japan and USSR did sign, and I believe the early 1950s, that one. So let's put a benchmark at this time when kind of the big whaling for right whale countries signed off. The population or the eastern population was about 500 animals. Since that time, there was, like I said, a right whale that was taken off of the Cole Harbor whaling station in 1951. So this is listed as an accident. So they believe, they thought it was a gray whale or humpback, didn't realize until after the strike. And so this animal was brought to shore and a person did a necropsy or an animal dissection. So that's how we know he was recently section matured, 12 meters long, a lot of kind of health metrics of this animal. And if you might be wondering why, there was still whaling in Canada and in the US, we still also had shore-based whaling. A lot of it was to provide animal feed. So I'll just leave it with that. After that time, jumped one more. Okay. Well, those are going to be connected now. I might have gotten rid of a slide on accident. Okay. Doesn't matter. There were 13 whales that additionally were taken from Japan, and I had this cool map of where that was, which isn't showing up. I apologize. So there were animals taken from the eastern and western population. They were taken under Article 8 of the International Convention for Regulation of Whaling. Some people call that scientific whaling permit, but it's called Article 8. And so those 13 additional animals were removed. Important additional legislation for the US, 1972, the Endangered Species Act. Okay, so it's just out of order. So this is the map showing the Japan takes. So you can see, was it 4 animals from the western population and the rest probably from the eastern. 1972, we also had the Marine Mammal Protection Act. So this is really important legislation because, for example, if a company wants to do oil and gas in an area that happens to have an endangered species or a critically endangered marine mammal, right, there's legislation in place of how to handle that. Oh, this is so interesting. This is a different slide. Okay, got rid of a slide, I guess. Okay, so it wasn't until, sorry guys, it wasn't until the 1980s when there was really kind of this global discussion about a moratorium from kind of a grassroots effort. So I would say like the average person is saying, I really care, in some countries, I really care about whales, and I think that we shouldn't whale anymore. So for example, I believe this photo is taken from the UK because I see things like Sussex and rugby. And I just want to point out my favorite part of this photo is someone's wearing a Creature of the Black Lagoon mask. So of the time. And I also just want to comment that, this is when I would say arguably many countries were on board with this because, again, it was a grassroots effort, but there are still today, countries which whale for various reasons. So it's always a dynamic kind of document and discussion, and the IWC always has value. Okay, so at this time, the late 1980s, people noticed that they really weren't seeing right whales like at all, especially in US and Canadian waters. And that led people to ask why. Again, the question was, were the scientists wrong in 1950? How come in 30 years we went from maybe 500 animals to like I'm barely seeing any? And the answer is quite sad. It turns out that there was extensive illegal whaling at this time. So over 500 right whales were taken by the USSR in the 60s, for example. They did take them, I believe, from both the Western and Eastern, but many from the Eastern. And so you can see how that would kind of fill in the gap of how we thought there were hundreds, and now there's quite few. And I think what's really interesting about this, I mean, it's all interesting, but what's really interesting to me is that, this wasn't formally announced in kind of scientific literature until 2012. So that is less than 20 years ago that we have gotten this big kind of data point of, again, a further extraction of a bunch of animals from the population. And the research that went into that study is fascinating, and it's its own talk. It's led by Dr. Yulia Avashenko, who was born in Russia, but living in the US, but went back to Russia and did pretty much a bunch of sleuthing detective work, talked with whaling captains, just so much excellent research to uncover, the numbers, which helped us fill in the gap. Okay, so let's get into the science now. I heard the 90s were back. That's why I did the rainbow. Okay, so like I said, in the 80s and before we knew about all the illegal whaling, people were just like, maybe Eastern right whales went extinct. Maybe they joined the Western population. Maybe we don't understand it's one population. But in 1996, on a survey, scientists that were looking for other marine mammals came upon some right whales. And it was very, very exciting. I believe it was in the Bering Sea. And it led to a whole bunch of scientific surveys. So again, scientists going out on cruises with the goal to find more right whales. And this was, I would say partly possible because of things like the Endangered Species Act, Marine Mammal Protection Act, etc., which are saying that, hey, we have whales here. We need to figure out, baseline information. How many? Where are they? What are they doing? And on these surveys, one of the things that they were able to do is collect skin samples called biopsies. And these biopsies are extremely valuable for science. They can provide information about genetics and sex and diet and health and all sorts of information. So how it is collected is that a scientist usually has like a modified crossbow with a little dart on the end, will come upon the animal and dart it, and a little bit of skin will be in this little dart, and then it kind of bounces off the animal and floats in the water, and the scientist will go and pick it up. And the size of the sample is about the length of my pinky nail, not the whole pinky, just the pinky nail around. So it is a good sample, but if we remember the size of a semi-truck, right, it is relatively small. And like I said, the wealth of information we have gotten from these samples and continue to get from these samples collected decades ago is just unbelievable. Like, for example, it's what led to those initial discussions back in 2000 to say, do we have enough genetic support now to say that right whales in the Northern Hemisphere, maybe there's two different species, maybe there's an Atlantic and a Pacific. And again, that's very important because if we can't lump them together, then we have to do those baseline assessments. We have to understand how many there are and where they are. That initial research led to the species designation of Japonica in 2008. So again, the North Pacific right whale hasn't been formally recognized as a distinct species for very long. Those skin samples also went to more recent genetic studies, which have confirmed that the Eastern and the Western population are different. And that is also extremely important from a conservation management perspective, because if the Eastern and Western, it was just one species, then you could argue, well, we don't really need to protect the ones off Alaska. We can let those go extinct because we're not losing anything from a genetic or a species perspective. But now we can say, okay, they are two different populations, so we have a different stock, and therefore they deserve to be known about and thought about from a conservation perspective. 2011 is the year when we have our only population estimate, so it is wildly out of date now, almost 20 years old. But this was also possible in part because of those biopsies. So we have a genetic population estimate as well as a photograph. So that marker capture. Remember, like I said, where's animal 354? How many years do we see him or her in what area? Those photos contribute toward a statistical measure called a population estimate, which is very important. So yeah, from 2008 to 2011, we identified this new species, and then we said, oh man, there's not very many in this eastern population. 2012 was an important year for science for these animals. Again, that was when it formally was recognized the extent of the illegal whaling, so that helped fill in the gap for a bunch of people in terms of why there were only 31 animals. And it was the year where we published the first high-low latitude match. So what that means is the same right whale, so this is animal number NIML9, was spotted in spring off Hawaii. And then that same year, a few months later, he or she was spotted off Alaska. So that is extremely important because it tells us that one animal is making these very large distances and gives us insight into where they may spend part of their year. And this was particularly important because, like I mentioned toward the beginning of the talk, one of our big mysteries is where are they in winter and what that means. And we always hypothesize and make assumptions, oftentimes based on what we see in other right whale species. So, for example, North Atlantic right whales undergo a kind of migration. They spend their summers feeding at high latitudes, and then they migrate to lower latitudes for calving. And so we have hypothesized that Pacific right whales might do the same, but haven't had really any support until that match. And still, that was only an adult, and that is only our only high-low latitude match to date. You might be wondering why it's important to identify that stuff, not only just to protect the calves, but it raises questions of how and where do animals get to where they need to go. So this is showing ship traffic density in winter in an average. So the more red means the more traffic there is. And so you can imagine, right, if our right whales are leaving their feeding grounds and going somewhere, let's say Hawaii's an option, maybe California, maybe even Canada, how they get there, so their migratory route, how long they spend there is really important. Because if they're going on a route where a lot of vessels go, that could make them vulnerable. For example, I'm sure many of the audience know the just horrific story of the North Atlantic right whale. Both of these are pictures of a North Atlantic right whale. That top left is animal so entangled in fishing gear. You can see its baleen is just completely out of whack. That animal is not able to efficiently feed, like how I talked about, and is extremely unhealthy. And then we have the potential also for ship strike. And in addition, we have the idea of perhaps negative impacts from things like noise if they're in very busy areas for extended periods of time. So these are very important questions, which are extremely difficult to answer when you have a population of less than 50 animals. So what we've done is that we really have relied on our sighting data. So anytime we have a confirmed yes right whale, either we have a photo or a video, because gray whales can look very similar to right whales, it gets put on a map like this. And then from this, we have learned about their distribution. We have noticed that in the summer, they kind of do what a right whale in the Atlantic does. In summer, it appears to be at higher latitudes, likely to feed. And then in winter, specifically in spring, so about starting in March, we see them Mexico, a couple of times in Hawaii, and also California. So you might be saying, Dana, it looks like you've solved it, right? Like, looks like that's the answer. It's not, because the big kind of missing piece is that none of these sightings at the lower latitudes have been of a calf. So we still don't know where the calves are going. We don't know where reproduction is happening. We don't know where the calving grounds are. The last time we actually saw a calf was 3 calves in 2004 on a feeding ground. So it's been a couple decades. However, we have seen a few juveniles. And so juvenile was a calf at some point. So we know reproduction is still happening, which is very encouraging. We just have an incomplete picture of what's going on. And you might be going, well, there's only 30. Maybe you're just not seeing the calf, right? Let's think back to that animation I showed and how many vessels were going, for example, to Hawaii, right? I imagine if the whalers were seeing moms with calves, they would target those moms because they might be going slower, might not dive as deep, right? And there's really nothing in the records about that. And also at that time, if you go, okay, Mexico, California, there was a lot of gray whale whaling happened. And again, just nothing jumping out in the whaling logbooks. So it is still an active question. And so I want to highlight that, most of these sightings, I would say easily 60% plus from this map, let me go back, are from not scientists. So they are from people like you, maybe on your sailboat, maybe on a whale watching boat, maybe a fisherman, maybe the Coast Guard, fill in the blank. Those are where these sightings are coming from, because people are seeing them, and the more eyes on the water looking, the more helpful that is. And again, their rarity, each time we see one, it's a very, very critical data point. So you can imagine that you could be the person who sees a calf, which would be amazing. And then what if you saw one at a southern latitude and could really help us crack some information in the calving grounds? That would be, I think that there's probably less than 10 people in the world who've seen a North Pacific right whale calf that are like alive today, especially Eastern population. So you would join a very elite club. I've actually never seen any North Pacific right whale. So that is on my bucket list. So if you do see one, what can you do, right? Because I showed you the map. Maybe you live along North American coast and you're going, okay, what do I do? First thing you want to do is slow down, right? Because there are speed restrictions, they're country specific. So it's good to be informed, but slow down. You have to stay, again, if you're seeing one in the US, 500 meters away. If you are like, oh my gosh, and you're just so excited, you zoom up on it and you take a video from 100 meters away, you'll probably get fined. So stay 500 meters. That's because they're such an endangered whale. That's why the distance is relatively far. Take a photo or video of the head. Again, that helps us distinguish from a gray whale. And then write down as much as you can about the encounter. Was it just one animal? Was it one looked small and one looked big? Did it look like it was doing the weird mowing the grass thing? Any information can be extremely helpful. Okay, let's go back to our cool science happening. So also in the 2000s, we had satellite tag studies happening. So a satellite tag is kind of like a little like splinter tag. It is living, it's implanted onto the outer skin layer of the whale, and it lasts for weeks to months. And the idea is that it's going to give a lat long every so often. And from that, you can figure out, where the whales were and answer questions about, what is important habitat for these animals. Because again, back in the 2000s, before the population estimate, just when we still really didn't know very much. So we were able to tag 4 animals. And you can see that they kind of all were in a similar area, which is cool. And they were all in this blue pentagon, which I'm calling the critical habitat. So the critical habitat was designated in 2008 and was really based on the sighting data, and is considered, one of the core primary habitats for these animals. I know I'm getting low on time, so I'm going to speed up just a little bit. So in addition to these visual surveys, one of the primary ways we study these animals, and my area of expertise, is using passive acoustics or listening. So again, those underwater microphones called hydrophones that are sitting close to the bottom, they're just actively recording ambient sound, from the ocean. And then a human like me will go through and will identify the various creatures that are in there. So for right whales, we're using 2 call types, the up call, which is on the bottom, and a gunshot call on the top. And I know the audio is not going to come through, so I'm going to become a right whale for the night. I apologize. But the up call sounds like we'd expect, just whoop, kind of that classic whale sound, right? Like Finding Nemo vibes. Whereas the gunshot call, it sounds like a gunshot. So I can do a very poor imitation, but it's like a kind of sound. So that's what we are looking for when we're going through the data. And what passive acoustics lets us do is, so we have our visual surveys, which might, go out for weeks, right? So a vessel can go out for weeks, but it can't go out for months and months, but our acoustic recorders can listen for months and months. So what it taught us is that, yes, we are hearing right whales in that critical habitat pretty much the whole summer and fall. So when there isn't ice. So from about May through December. So that is very important. Also confirm that, yes, we're not hearing them in winter. So maybe they're going somewhere else. Some of the other cool research that we've done in the recent years is that we have expanded our recorder network to other areas where we think right whales could be based on the historical whaling data. So one of those areas is the Aleutian Passes. And the idea is that maybe these whales, if they are leaving the feeding grounds, they're passing through these passes, maybe they're migrating along the coast, or maybe they're just going offshore. So these passive acoustic recorders can help us answer that. We can also use this cool tool called a sonobuoy, which is a floating microphone, which you can throw overboard at sea. And so what it does is that it actively transmits in real time the acoustic data back to the boat. So you as the scientist can listen to exactly, what's happening in the water. And this is really, really helpful because, for example, on those surveys, these whales, especially in Alaska, they love to be in the fog and the rain and the really wavy, right? It is usually not great conditions out there, but if you have acoustics, it doesn't really matter what's going on above the surface. And so what you can do is you can say, okay, you can throw out a couple sonobuoys. You can use trigonometry and say, I have a fix. I think I'm hearing a right whale a quarter of a mile that way. The boat can go over there, and then the visual people can go, oh yeah, I see one, right? And you can get the photo and the biopsies and everything. So it's a really cool tool that lets us conduct some additional research at sea. In addition, a really exciting finding came out in 2019 by my colleague Jessica Krantz, where she uncovered that North Pacific right whales can actually produce song. So kind of like, humpbacks can sing, they do produce song. We're still trying to figure out what it means. Is it also a reproductive display or something else? But it was really exciting because we're usually the small population that doesn't, we don't know anything about. And this is the first time we published something really cutting edge because right whale song had never been published for Australis or Glacialis before. So we felt like we, were really, really accomplishing something exciting. 2025, we heard right whale calls south of Bering Strait. So that's where Russia and Alaska get really close to each other. That's important because that's the only way in and out of the Arctic from the Pacific side. So it's an important vessel route, like you can imagine. So that tells us that we should be listening and looking for whales in that area. And especially, with decreasing sea ice. And so that, led us to do work with our copepod scientists who noted that there's a lot less copepods on the whale's primary feeding ground in recent years when there's less ice. And the hypothesis is that those copepods really like to feed on ice algae. So if the ice keeps moving further north, the food will move further north. And our acoustic data can help answer if the whales are moving further north too. So that is an active area of research. We've also been participating in International Whaling Commission surveys. So, that's been extremely insightful. So these are big surveys out of swaths of the Pacific Ocean. And one of the major findings is that they did uncover a juvenile named Phoenix in 2017. So anytime we can find a juvenile and add a new animal to the population, it is very exciting. We also can get biopsies off those surveys. So we are still adding to that biopsy catalog. And as new and cool science comes out, like for example, we can do chemistry on these skin samples. So we can take a tiny slice. It's called biogeochemistry, say isotope ecology. Not going to talk about that, just to show you that, you see kind of clumps and then not clumps, right? And that is actually really informative and telling us things about kind of the health and the diet and where these whales are found. And I will end with the opportunistic sighting. So again, during this whole time, some of our major findings have come from these opportunistic sightings, so not dedicated scientific surveys. It allows us to make things like these maps, which have been invaluable. One of the highlights, I will say, and I'm just going to do just a couple, is there was a sighting of animal off British Columbia in June of 2013. This happened to be the first time a right whale had been seen since this juvenile that was killed in 1951 that I talked about. So that's 60 years where a right whale had not been seen in Canadian waters and then was seen in 2013. And then lo and behold, a different one was seen just a few months later that same year. So that was super, super exciting for folks. We have seen a right whale near Bering Strait in 2018. So that's 6 years before we heard them on the detector. So that just supports having complementary data is important. 2020, another animal was seen off of Canada, and actually there was one in 2018, but I wanted to highlight this one because it was literally seen off of a container vessel. So again, however you're going to see it is amazing. Just to highlight one from California, one seen off Coral Bank National Marine Sanctuary. And then I'll end with this most recent sighting in June of 2026, so only 2 months ago. Another animal was seen off of Canada, and this was a very happy, healthy juvenile male. So this male was spotted by scientists that were actually looking for other marine mammals, but they saw the right whale. And again, diverted effort to get these photos. This is a cool drone shot that they have. And one of the things they commented on was, no entanglement scars, and that all day this guy was just rolling and playing in the bull kelp. And only a happy, healthy whale is going to do that. So it's very, very encouraging. So I know I went very long. I apologize. I'm happy to stay after to answer questions. And I thank you so much for listening. And yes, let's chat more about right whales.
It was an amazing talk. Thank you so much. Do you
You're
want to
welcome.
stop sharing your screen so we can see you full screen?
Sure. Oh, is this me from drawing? I apologize if I made these lines.
Yeah, there we go. All right. I know I saw a couple questions already. So okay, let me go back to some of the really early on questions. Okay, there was a question, one of the first ones about how many unique individuals have been photo identified, but you already kind of answered that already in your talk.
I will say that
That's
we are actively adding, like every couple years. It's anytime we get a sighting, there's a high likelihood that it's a new animal. So it's really encouraging.
okay. All right, here's a new question. What size group do they travel in, and are offshore orcas natural predators like humpbacks?
Great question. In terms of the predation, we're not sure. Again, the likelihood of witnessing one of those predation events is low, but it's definitely possible. It depends a lot on their migration routes, which we're just their incomplete knowledge. But we do think that they are relatively solitary creatures. A lot of times they're seen in individuals or just groups of two. And interestingly, a lot of times on their feeding ground, so in that critical habitat, you will see one right whale and a group of humpbacks. So we're not sure if what's going on there. Is that a lonely right whale, or are they hearing a humpback munching and so they're following, so that's really interesting.
Question below that was, do they use echolocation to find food?
Great question. Echolocation is usually used by toothed whales. So these guys are using lower frequency sounds.
Was the juvenile sighted off of Port Hardy this June 2026 new to the catalog or already known?
I believe it was new. Yeah, I'm pretty sure that it was a new guy. I think Kate could comment on that too.
Okay. With the eastern population so sparse, how do these animals find each other to breed?
I'm not sure. Again, we know the juveniles exist, so that means calves exist, so that means reproduction is happening. We don't know where they are reproducing. Other species of right whales, they aggregate and will reproduce in groups. So it would make sense that the few number of right whales, either there's a historical reproductive ground where they know to go to, or perhaps they have created a new one in this small population size. But where that is, I'm not sure. And the mechanisms of them coming together in the Atlantic, it's usually, again, historical. So, they know it's September, we all go to this area because we know that's where reproduction is happening.
Okay, we got more questions for you.
Yeah.
Where did you get your baleen specimen that you showed us?
Yeah, that's a great question. I got this guy off of Ukayavik, formerly Barrow. So it has artwork on it. So an Alaska native drew this artwork, and so because of that is allowed to be sold. So this is something that I purchased. And yeah, I will say, I forgot to say in the talk, but it's relatively short. So bowhead baleen can also be 8+ feet long. So this is likely from the front of the mouth, which is why it's so short.
Okay. Can the pods interbreed and expand genetic population?
Great question. Yes. So that was one of the core um, motivations of that 2022 study to say, we think there's an Eastern and Western, but genetically, is that supported? Are they kind of just spatially, we see them in different areas, but again, we don't know where they're reproducing. So maybe the two different groups are coming together and reproducing together. But if you look at the genetics, it looks like they have been distinctly different populations. So not interbreeding for historically quite a long time to be considered distinct populations. Who knows why that is? Because again, they're not that far away from each other. So we've asked questions of, they produce song. Do the different populations produce different song to identify an Eastern versus Western? Could in the future the Eastern and Western interbreed? That's always possible, but to date we haven't seen evidence of that.
Okay. What is needed to be able to do another population study? Curious how the population estimate from 2011 could be updated.
Yes. So we are actually actively updating it right now. So what you need is more photos. So the more robust data, the longer the time series, the more areas that you are collecting your photographs from, the more accurate. So we are hoping to provide an updated estimate in the next couple of years.
Okay. Does ship noise interfere with their ability to find food and eat other?
Yeah. So the ability to find food is interesting because we're not sure the mechanism that they find food. So some of the hypotheses are that they might have sensory abilities to almost smell their food in a way. But in terms of, again, they don't use echolocation to find food. So they might be like, for example, I said they might be eavesdropping on another animal, that when it's eating, it makes a certain call. So they know, okay, humpback's eating over there or something. So the exact mechanisms of how they find food is still active area of research. And will you read the second? Oh, find each other, right? I think was the second half.
Yes.
Yes. Okay. Finding each other. Yes. I will say that the Atlantic population, there's a lot of research that's been done. And it has shown, for example, mothers with calves, they say they whisper. So they call at a lower amplitude. And the question becomes, if it's a very noisy environment, is that going to impact their ability to communicate? And then, yeah, also the idea that perhaps in a noisy environment, you can't hear a conspecific or another animal. So yeah, that's a place where I would say that North Atlantic literature knows a lot more. And those are really active questions because they are considered the urban whale, living in a really noisy environment.
Okay. What research is going on by the Asian fetologists on right whales?
I'm not sure what they're asking.
Paul, do you want to just unmute yourself and maybe clarify your question?
Uh, Hey, you're asking me?
Yes.
Yeah, I was just curious, which countries on the Asian side of the Pacific are they doing research on right whales also? Is Japan doing any research? Taiwan, South Korea? Could
Yes,
you
great
comment on
question.
that?
Yes, so Japan is actively doing research on right whales and other whales. So they actively participate on that IWC survey that I talked about. They send a few scientists out on that. And I know that they also conduct their own in country aerial surveys. So they use airplanes and also vessel surveys. And they're surveying for more than just right whales. So they're kind of trying to figure out all whales that are around. But yes, they're actively conducting research. And I believe they're also doing acoustics as well. In terms of, I'm not sure what Russia's doing. I know historically, like the 2018 sighting I mentioned, I believe collaborator or first author. Yeah, so they also are actively doing research as well. Taiwan, I'm not sure.
Thank
Follow-up
you.
is possible. Can I do a follow-up?
Sure.
Sure.
Are any of those countries making container ships and oil tankers slow down as they come close to the migration patterns of those whales? I know not much is happening in our country, sadly, but I'm hoping some other countries are trying to pay attention and slow down the boats, the ships. Do you know?
Yes. I don't believe so. It's to my knowledge, I don't believe so.
Okay. From a sighting from a distance, is their blow size shape distinctive?
What a great question. I had slides on this and I was like, I don't have time to talk about this. Yes. So if you think you see a right whale, it's from a distance, they will produce a heart-shaped blow. And so it's not extremely tall. So for example, a humpback is very bushy and tall blow, one single, but these guys make a heart-shaped blow. But you have to be careful because gray whales can also make a heart-shaped blow. So make sure you get the shots of the head.
All right. Are there aerial surveys for the eastern North Pacific right whale population or mainly boat-based and opportunistic sightings?
Yeah, great question. It's mostly boat-based and opportunistic. Most of the aerial surveys are in the Arctic, and so it's for bowhead whales, gray whales, etc. And I believe a lot of that is just due to, again, the low population size. So the likelihood that a whale will be surfacing while the airplane is going by, it's hard to justify a study like that when in comparison you can put an underwater microphone and probably hear them go by. But it's a great idea and everybody would love to have that for sure.
Is there a difference in the blow height between Wright and gray?
I'm not sure. Yeah, I'm not sure if one is a bushier, right, more of like a bigger heart and one is a tighter heart. I'm not sure. You'll have to see one and let me know.
All right. Any other questions?
These have been great questions.
Yeah. Yeah. Okay, going once. Yep. Okay. Has there been new attempts at tagging whales to assess migration patterns?
Yes, great question, Sebastian. No, there has not. So there is kind of it's again that problem of number. To do a tagging study is quite expensive because you have to have a big vessel that can go out and then a small vessel which can get close to the animals. And then you have specific scientists that are trained to put tags on and make sure they don't hurt the animal. So it's just a big financial investment and the likelihood of seeing a whale and then having the weather be good enough to put the tag on, it just hasn't happened. However, I have been on surveys where, we have the permit. So even if we're looking for a different whale, if the conditions are right, there might be an attempt to put one on. But in terms of a dedicated tagging study, that hasn't happened since the 2000s.
Okay. Last chance for questions. Go once, going twice. Okay, okay. We got one more. Some gray whales swam the Northwest Passage. Do right whales swim into high Arctic Ocean?
Yeah, that is a great question. So interestingly, in terms of the past 30 years or so, a sighting north of the Bering Strait, so going to the Chukchi Sea or like the Arctic, hasn't been documented. Just getting close to the Bering Strait. If you look at the whaling data, it is complicated because there was a period of time in the early 50s, 1850s, when again, we really had taken a bunch of right whales and those whalers, quote unquote, again, discovered this new type of right whale, which was even bigger and even longer baleen. And what they actually discovered was the bowhead whale. But there was a couple years where they were not calling it a different type of whale. And so there's record of kind of right whales being seen or taken in the Arctic. And it's unclear if those are actual, Eubalaena japonica or Balenidae mysticide bowhead whales. So the historical comparison is murky, but I think people are comfortable saying the Bering Strait is kind of the northern extent of today. The question becomes, again, if the food starts going further north, will they keep going further north, or will they maybe switch to a different type of copepod or switch to krill? Those are open questions for sure.
Okay, so I see two remaining questions, and we will make them the last questions, and then we gotta let Dr. Wright go. Okay, are drones used in research?
So drones are used in research. So the photo I said again, the photo of the juvenile from this past summer, that was drone footage from scientists in Canada. That was again an opportunistic sighting. So those scientists weren't actively looking for right whales, but once they saw the right whale, they were able to deploy a scientific drone, and the drone was able to, again, because they have a permit, you're able to go above the animal. The average person, it's illegal to use a drone too close to a marine mammal, but they had a permit to go above the animal. And drones are actually extremely helpful, because if you can get a picture of the whale straight down and you can see its head and you can see its tail, you can estimate its length, and you can also estimate its girth, its width. And that can, again, tell you things like, is it a juvenile? It can tell you, is it relatively healthy? And if we can track that whale, like, for example, if they see that next year, they can go, okay, that whale grew 3 meters this winter, right? And we can start to gain some information about the biology of the animals. So yes, I would say it's used when possible.
Are there hypotheses on why the recovery of southern right whales seems to have been so much faster than North Pacific right whales?
Yes. One is that I believe those populations in general were not brought down as far. So there were more animals left to help, again, rebuild the population. Also, they didn't have extensive illegal whaling, taking them out up into the very recently, which helps them recover. And I think there are so many different little subpopulations that I think they have the capacity to rebound, because the whalers were kind of taking a few animals from a bunch of different populations instead of almost all the animals from, just the 2 populations that exist in the Pacific, if that makes sense.
Okay, we have one last question that got snuck in here, but this
Yeah.
is it. We really have to let Dr. Wright go. But okay, is eDNA an option to use to track or locate right whales?
Yes, Diana, that's a great question to end on. And I would say yes, with a little asterisk. So if for example, somebody calls in and says, I think I see a right whale, and we go, oh man, cool, and you can get a scientist out there and they can get a water sample, like maybe they didn't get the biopsy, but they can get a water sample. Yes, we could do eDNA, and from that we can say, yes, we can confirm it's a right whale. We might even be able to say its sex, might even be able to say the individual. So it's very exciting. However, eDNA it's not that expensive, but it's not inexpensive yet. So it's really implemented when we think when we have a good hypothesis that we're going to find a whale in the sample, if that makes sense. So we're not just going to take thousands and thousands of samples from the ocean and process them, because it's just very expensive. But if you have some idea that, okay, we think this is a calving ground or something, let's start taking samples every week, that could be implemented. So that's very cutting edge. That's something that people are thinking about into the future, of kind of a low cost way to do science, for sure.
All right. Well, Dr. Wright, again, thank you so much for joining us this evening, and
Yeah, thank you.
staying after 7 to answer all the questions. You saw there was lots of questions for you. It was a really interesting talk. We're so appreciative to have you speaking with us tonight.
Yeah, of course. Anytime. Thank you so much. Thank you so much for asking great questions and being so engaged, everyone. I really appreciate it.
And folks, we will have a recording of this. We'll make it available on our website. Give us some time to get that posted and up there. And another update before we leave. So we will actually be live streaming our last lecture. So that is exciting. Yeah, so it's not just going to be a recording. We'll have it live at the Whale Museum for September 1st talk, and we'll have it live streamed in real time too. So again, I want to thank everyone for joining us tonight. I hope you guys all have an amazing evening, and I hope you guys will participate in future Whale Museum events and activities. And I'll give a second to close out for folks, in case you do want to save the chat. Again, remember there's like these three little dots, and if you go to the three dots, it'll say save chat. And if you want to save the chat, you can. So I'll just give it a minute here and then we'll close out. Yes, thank
Thanks,
you again,
everyone.
Dr.
Of course. Yeah. Thanks for inviting me. Anytime. I think I shared everything there is to know about right whales, so we'll have to wait for 10 years before I give an update.
All right, guys, I'm going to end the meeting now. Bye, everyone. Thank you for joining.